Hello everyone, this is KINGSINE. Let's explore the differential protection testing module. To begin with, we should configure parameters in the test objects section, where we'll select the protected equipment type as transformer, generator, motor, or busbar. Now, when choosing windings configuration, we can pick either 2 windings or 3 windings, but remember that 3 winding applies exclusively to transformers. Moving to balance coefficient, we've got flexibility here, calculate them based on rating values or currents, or input them directly. Next up is system parameter setup. This is where we match the tester's settings to our protection relay actual setting values. We'll enter values like power ratings, voltage and current levels, and wiring configurations. For reference current, we'll encounter 2 industry approaches: protected object nominal current or CT nominal current. Since every relay manufacturer implements these differently, we should consult our specific device's documentation to set this correctly. Keep in mind that zero sequence elimination only relates to single-phase faults. The calculation model, that's determined by our relay's make and model. Here's a time saver: we can import configuration file to automatically configure these parameters. Now let's define differential characteristics, the heart of this test. We'll add, delete, or modify current, restraint, and curve settings using our tools. We'll notice the No Combined Characteristics option. Activate this because during normal operation, protection relays filter out large differential currents. Disabling composite features prevents healthy phases from false tripping during tests. Once configured, simply apply and exit to return to the main test screen. Now let's check out the hardware connection. We use KF86P for differential test today. We connected IA/IB/IC to primary current, IX/IY/IZ to secondary current. We connect 1 pairs of binary input for trip signal capture. For actual testing, we simulate internal faults within the protection zone using 2 methods, shot test and search test. We first check out the shot test. In the differential characteristic graph, right-click to add test points or manually define them through differential and restraint current settings. After addition, we can see all points automatically organized in a test table based on fault type, while the vector diagram dynamically displays calculated currents for primary and secondary and shown with corresponding current channels. Each test point evaluates tripping behavior using our preset differential current, restraint current, and fault type, with timing governed by our differential time settings. When creating search test lines, click directly on the graph or input fixed restraint currents. Why fixed? Because during line searches, restraint current remains constant while our software sweeps differential current across values. This method pinpoints the exact trip threshold between restraint and operate zones. Results are then evaluated against our predefined current and time tolerances. Once the test is completed, we can assess results as passed, failed, or skip assessment entirely. Moving to report setup, here we can upload custom logos, add descriptions, and select long format reporting. Next, navigate to Test Object where we preview the full report layout. After verifying all details thoroughly, simply save the finalized report. This completes our workflow. Thanks for watching our video.